cups, we're going to deal with things like ions or molecules or compounds. So I have 1 mole of ions for every 6.02 times 10 to the 23rd ions. Same thing with a dozen. If I had 1 dozen, then I've got 12 of something, whatever that might be. If that's cars, great, I have a dozen cars. So it's a similar concept. It just gets confusing because it's a big number with an exponent and a decimal. Don't let it confuse you. It's the same thing as a dozen. Alright, so let's erase this and let's do some work. So here we go. We have 20 grams. Write down what you are given. You're given 20 grams of sodium carbonate. So here is 20 grams. Sodium carbonate. You need to figure out what that is. Sodium, and there is the carbonate ion. Carbonate ion is 2 minus, the sodium ion is 1 plus. To balance that out, you're going to need 2 sodiums. So I have 20 grams of sodium carbonate. When I take that, I'm going to use dimensional analysis to convert it into what they're asking me for, what I desire. I desire moles. I desire moles of what? Of sodium carbonate. So now I need to figure out, well, I put my desired unit on top. So if I desire moles, I put 1 mole of sodium carbonate on the top of my ratio, which is my numerator. And then I want to convert out of grams. So I put grams in the denominator. But I don't know how many grams there are for every 1 mole of sodium carbonate. So I need to figure that out. So I look at my periodic table and I say, well, sodium weighs about 23 grams for every 1 mole. Carbon weighs about 12 grams for every 1 mole, and oxygen weighs exactly 16 grams for every 1 mole. Should have made that over a little bit farther to the right, but that's okay. So now if I take that and I multiply, let's move that over a little bit further. If I multiply this sodium times 2, and then I multiply the carbon by 1, and I multiply the oxygen by 3, and I do this because there are 3 oxygens for every 1 sodium carbonate, and there are 2 sodiums, I will get 46 grams, I will get 12 grams, and I will get 48 grams. When I add those numbers up, I get 106 grams. 106 grams for every 1 mole. For every 1 mole of, you said it, sodium carbonate. Ran out of room a little bit there. See if I can scroll over a little bit more. Okay, now I'm going to take that 106 grams and I'm going to put it right there. Now I could put some decimals. You notice that I rounded here. If your number on your periodic table for the mass of your element is within a tenth of a whole number, then you can round up or down. So 23 wasn't 23, it was 22.9 something, right? So that means you can round that up to 23 because it's within a tenth. What is it, tenth? Tenth is a 0.1, right? Or a 0.9 is within a tenth of a whole number, or 0.1 you can round down. When I do this in my calculator, everyone use a calculator, please don't practice with your phone. 0.189 moles of, I'm going to write it below because I ran out of room, sodium carbonate. And always box your answer. It'll make it easier. It'll make it easier to read for whoever's reading it. You want to make that person happy, right? Okay. Calculate the number now of sodium ions. So this is a little bit harder. It takes a few more steps. So I'm going to take this number of moles. So I'm going to write that over here. I'm going to change colors, give a little bit of, make it easier to distinguish. So if I have 0.189 moles of sodium carbonate, and I want to figure out how many, sodium ions I have. Well, there's 2 ways to do that. Well, there's probably many ways. I'm going to show you 1 or 2 ways to do that. I want to convert out of moles. So I'm going to put 1 mole of sodium carbonate down here. What I'm going to put in the top is I'm going to put 2 moles. This is how I would prefer to do it. 2 moles of what? 2 moles of sodium ion. Why are there 2 moles of sodium ion for every 1 mole of sodium carbonate? Because there's 2 sodiums for every 1 sodium carbonate. Just like if I asked you how many oxygen atoms there are, I would have put a 3 here, and I would have said 3 moles of oxygen atoms. But here I'm doing sodium ions. Now, I would get the number of moles of sodium ions if I multiply this number times 2 and divided it by 1, but I don't want that. I want the actual number, not the number of moles. So what I'm going to say is, if I have 1 mole, because I want to convert out of moles of sodium ions. If I have 1 mole of sodium ions, for every 6.02 times 10 to the 23rd sodium ions. Now I take that number 0.189 and multiply it by 2. Then I multiply it by 6.02 times 10 raised to the 23rd. What I get is 2.27 times 10 to the 23rd. So I put this number in here. I have 2.27 times 10 to the 23rd sodium ions. And I'm going to scroll over here and try to make a nice little box. As you can see, I kind of ran out of room. If I box my answer, it makes it a lot easier to distinguish between my work, which is over here, and my answer, which is over here. And this isn't beautiful, and some of you students that I teach have much better handwriting than I do. I'm writing on a computer, and I can read this. I hope you can too. Let's move on to the next page, which I can't find at the moment, but I will in a minute. Alright, there it is. So on this page here, this is, I'm going to make this a little bit bigger. This is giving me 0.458 moles of calcium hydroxide. Alright, so if I have this 0.458 moles of calcium hydroxide, what do I desire? I desire the grams of calcium hydroxide. Okay, before it gave me grams and it asked me for moles. Now it's giving me moles and asking me for grams. So we're going to do a similar conversion, but we're going to go the other direction. So if I have 0.458 moles of, I can't write the word calcium hydroxide. I need to write the formula for calcium hydroxide. Calcium is a 2 plus ion. Hydroxide is a 1 minus ion. So I need 2 hydroxides for every 1 calcium. So I have 0.458 moles of calcium hydroxide. That's my given. I multiply that times something. What do I desire? I desire grams. So I put grams up top. What am I getting rid of? I'm getting rid of moles. So I put moles on the bottom. Moles of what? Moles of calcium hydroxide. I could put grams of calcium hydroxide, but I already have moles per gram, so it's kind of understood that this is grams of calcium hydroxide. For every 1 mole of calcium hydroxide, how many grams do I have? I don't know. So I need to figure out the molar mass. Calcium on the periodic table weighs 40 grams per mole. Oxygen weighs 16 grams per mole, and hydrogen weighs 1 gram per mole. I multiply the oxygen times 2. I multiply the hydrogen times 2. What I get is 32 plus 2. I have 34 plus 40. So it's 40 plus 32 plus 2. I have 74 grams per mole. Per mole of what? I should write my unit. Per mole of calcium hydroxide. It's a little bit sloppy, but here I'm going to put 74 grams. And again, I could have put a decimal, but I just rounded up my numbers. This has 3 sig figs. My answer will have 3 sig figs. If you calculate your molar mass to the decimal, you will get almost the exact same number that I get. There's always a little bit of give in chemical answers by a few decimal places, so it's okay. So if I take that 0.458 and I multiply it by 74, what I get is 0.339. I'm going to put my answer in red so it's easier to see. So I'm getting a little crowded here. 0.339 grams. Grams of what? Grams of calcium hydroxide. And again, I'm going to box my answer so it makes it easy for you to distinguish between my work and this is my work over here, and this is my answer over here. Okay. Now, what about the number of hydroxide ions? I'm going to put that work right here. Okay, you might be tempted to work with this number of grams. That would be futile. You don't need to work with the number of grams. You want to work with the number of moles. Here's why. If I take my number of moles, I can convert directly from moles of calcium hydroxide into moles of hydroxide, which is what I want. I want hydroxide. That's what I desire. So I have 0.458 moles of calcium hydroxide. Now, just like in the problem before, I choose to say, well, if I have 2 moles of hydroxide ion for every 1 mole of calcium hydroxide, then I will get the number of moles of hydroxide ion. But I don't want the number of moles, I want the actual number. So I'm not going to put an equal sign there. I'm going to erase that. And what I'm going to do instead is I'm going to say, hey, let's multiply this times Avogadro's number. Because if I have 1 mole of hydroxide ions, then I have 6.02 times 10 to the 23rd hydroxide ions. And if I do that math, if I take my 0.458 and I multiply it by 2, and then I multiply that times 6.02 times 10 raised to the 23rd, then what I'll have is 5.51 times 10 to the 23rd, it's 23, hydroxide ions. Man, that 2 got very sloppy. And then I'll box my answer. And there you go. You've answered the question. I'm going to check the time here. We're at 25 minutes, a very long video. I'm going to stop this video and I'm going to go on to the limiting and excess reactant on another video just to make sure that I don't lose my data.